Hey guys, I wanted to make a quick video for you guys to go through the rules for naming covalent compounds. This is, again, covalent compounds only. We will go through rules for ionic compounds and we'll add to this graphic organizer after we learn about ionic compounds. So the first question when you see a compound is, does the compound contain two nonmetals? And in order for you to know that, using ptable.com, you can separate all of the atoms by metal, nonmetal, or metalloid. And it's really simple. I pulled this straight from ptable, and you'll see this line that occurs here. These are the metalloids. Everything over here is a metal except for hydrogen, and everything over here is a nonmetal. And again, to do that, you just go ptable.com, and I just highlighted the metalloids, and then that way it would separate those out very nicely for you. But does it contain two nonmetals? So two things from this right side or hydrogen. If yes, then it is a covalent compound. If no, if it has a metal and a nonmetal, then it is an ionic compound. These two words are actually linked, so if you click on covalent, it'll take you to the next slide that has the rules. If you click on ionic, it'll take you here, but again, we're not doing ionic today, so we'll just focus on covalent for right now. So for covalent compounds. All right, so there's two different things I added here for you guys. We're going to start over here on the right side, how to go from a name to a formula. So you guys have done a really good job so far in class of writing the formulas and understanding that the subscript represent how many atoms, how many particular atoms of that molecule there are. For example, CO2, 1 carbon, 2 oxygens. So what we're going to do is, if I gave you a name, this is going to show you how to write the formula. So first thing you want to do is write the symbol of the first element in the compound's name, then the symbol of the second element in the compound's name. Then you're going to tell me how many atoms of each element using those subscripts. And then how you know how many is based on the Greek prefixes. And just a special note that if there is no Greek prefix in the name, then the assumption is that there is only one of that atom. So let's go look at an example of this. So write the formula for dinitrogen tetrafluoride. Again, that's dinitrogen tetrafluoride. This is a common molecule. So first thing is to write the symbol of each of those. So I wrote N for nitrogen, and then F for fluoride, or fluorine. And then it says step 2 is to indicate how many atoms of each element the molecule contains using subscripts after the atomic symbol. And then how you know the subscripts to write are based on the Greek prefixes, and those are on slide 3 for you guys. So we need to know what is the Greek prefix for di, and then also tetra. So I'm going to go back to slide 3 to show you guys. Those prefixes are here. So it looks like di is 2 and tetra is 4. So to update your notes here, you need a 2 on nitrogen and then a 4 on fluorine. And then we need to make those subscripts. If you just highlight it, and then the keyboard shortcut is the control button and the comma button. So that'll make them real tiny subscripts for you really fast. All right, there we go. So that's how you write the formula of dinitrogen tetrafluoride. We'll go through one more example with you guys. Write the formula for carbon disulfide. So starting just by writing carbon C and sulfur S. Just a note, you're not going to find sulfide on the periodic table because the suffix "ide" has been added. You're going to find sulfur on the periodic table. When we name covalent compounds, we switch that to "ide" at the end. All right, so CS, and then tell how many atoms of each element based on those prefixes. So there's no prefix in front of carbon, so that means that there must be just one carbon atom. And then di for sulfur means 2 again, so we need this to say carbon, it just needs to say CS2. And you just highlight the number, control comma, we'll make that a subscript for you. So going from name to formula is usually a lot easier. Let's back up and learn how to do the opposite, how if I gave you this formula, how you would be able to get the name. So let me go back up to slide 2 of your notes. All right, we learned all that. So going from formula over here to name. So the first thing you want to do is list the name of the first element in the formula. Second, list the second element in the compound, but make sure you're changing that suffix to "ide," just like sulfur in the last example was changed to sulfide. Next, you want to use those Greek prefixes to tell how many are in each atom. And then there's a couple exceptions to the rule. First, if the first atom is if there's only one of the first atom, we typically don't use mono in that name. Like we don't say monocarbon dioxide, we just say carbon dioxide. So again, if the first atom only has one atom, we drop the mono. And then the O or the A at the end of the Greek prefix is dropped when the element name begins with a vowel. So for example, if you have 5 oxygens, we would think that that would be pentaoxide, but we just call it pentoxide. So we drop the A in penta, and it's pentoxide. So if you click here, we're gonna, okay, and then yeah, here's all of your Greek prefixes for your notes. You can pause the video here to get all of those written down. You'll notice that these are probably, some of them are probably familiar to you, like 8 is octa, like an octagon. So if you need to pause the video here, you can, so that you can copy all those down. Looks like 10 is cutting off, that's deca, D-E-C-A. All right, so we went through this one, we went through that example. So here's the opposite, right? So writing the name for N2S4. So we write the names of our first element, so nitrogen. Our second element, sulfur, we change that suffix to "ide." And then we use those Greek prefixes to determine, we use these numbers to determine our Greek prefixes. So 2 being di, becomes dinitrogen. 4 for sulfur becomes tetrasulfide. Here's another example. So write the name for SO3. Sulfur is our first atom. Oxygen, that suffix is changed to oxide. Use the numbers to figure out what our prefixes are going to be. So there's no subscript here, so we just leave that as sulfur. We don't typically say monosulfur, we just say sulfur. And then the prefix for 3 on our oxygen is going to be trioxide. And again, the note is just saying don't use mono for the first element in the name. And that's it, guys, because the next slide is on naming ionic compounds, which is not as complicated. It's a little more simple, but we'll get to that when we get to our little mini unit on ionic compounds. So on your Oz assignment today, once you have your notes copied over, giving you about 8 to 10 different problems to do. The first set, you're going from name to formula. So disulfur tetrafluoride, using those prefixes to figure out what the subscripts are. This is a paper assignment as well, so you'll want to get this from the sub. You do not have to type into this box, so you'll write these out and then just turn in this copy. Make sure your subscripts are easy for me to read, so that way it's going to be easy to check. And then the second set is going from formula to name, which again seems to be a little bit more difficult for some. But if you just follow those rules, you guys will be able to do that. you have any questions, send me a message.